So now let's continue off where we left. Probably we will be done with the slide and then I will send so that you guys can review and go through it. So on the previous session, we were talking about, we spoke about the great insulation. So let's see how do we move forward from here. So now we're going to talk about the energy while we still under matter and materials, how energy flows. We're going to talk about the flow of energy, right? So now we have different types of elements. We have iron, aluminum, glass, we have brass, we have copper. So these are most different materials. We have iron, Fe, aluminum, glass, brass, and Cu, which is copper, right? So we call them the rods, by the way. We call them the rods, the metal rods. So these metal rods are connected through a container through a container, and this container over here, it has hot water inside of it. Here we have a hot water inside of it, and then these metal rods are inside of this container where we have hot water. So now let me do it like this. Here I want us to do it like this. Okay, here's the idea. It's hot there, so we need to discuss the heat conductivity of these rods. Here's the thing. Having a look at Fe, aluminium, glass, brass, Cu, these are all different rods. How the energy is going to be transferred from this hot substance that is inside of this container to this rod, to these rods. It matters over what is the. You can also make use of this thing. Remember this: the best insulator and the best conductors. So the best conductor, it is the one that can conduct heat very, very, very well. So at some point, you touch Fe, you touch Al, you touch glass, you touch brass, you touch copper. There is the one that's gonna feel very, very hot when you touch it because of heat transfer. So remember, this is the heat energy, and this heat energy can be transferred in a form of kinetic energy, and then that kinetic energy can further be converted into heat energy when it gets into this hot. So it's either when you touch this one and this one is hotter than the other one is hotter than the other one is extremely hot. So that's basically how we can actually discuss the heat conductivity of these rods. Because remember, we have a hot liquid in here, which is same thing. Like when you put your spoon in a, or when you use, those dishes. We used to use them a lot back then in our days. Um, in Sesotho, they normally say ke ere. They say skotlolo sa ere, kopi ya ere. That's what they mean in Sesotho, right? That's what they say in Sesotho. It's a green dish, nyana, some sort of, it's like, it's made up of lezenge, but again, corrugated.
Se-
Yeah.
Ke a utlwisisa bua ka eng?
Oh, okay. Exactly.
Eh,
That those types of materials are very hot. When you put your tea inside of that cup, you would even struggle to drink out of that cup. But when you take the usual cup, the one that is made of glass, yes, it is still hot, but not compared to the other one that it is made up of a corrugated steel because it's super hot. You understand? That's energy flow. So energy will always flow from a high concentrated area to a low concentrated area. And so I'm saying to you, here we have different types of metals, and we have different types of materials. So these materials are all rods, but you have to understand that the arrangements of their properties are most definitely different. So the other one will feel hotter than the other one. The other one might not as well not feel hot because it's not good conductor of heat. Do you understand? That's how we can discuss the flow of energy. So based on this, we can see that here there will be copper. It is the one that has but again more water in less water in it, and brass and wabona this glass is too much there and whatnot and whatnot and whatnot. So it's a melted wax. There is a melted wax. So here it is melted. Or these rods like what? Or this is where it will melt. It will melt up until here, and then here it's gonna be unmelted. It will still look quite very good. Oh yeah, glass doesn't melt most of the times. And then a brass, it will melt partial there, over there, and then yeah, the second. So the first one that doesn't melt too much. Number one, we'll put a glass. Um, number two will be a brass. Number three will be Fe. Uh, number four will be Al, and the one that's gonna melt out too much is number five, which is Cu. Okay, so let's talk about the magnetic and non-magnetic materials. There's a lot of information, right? When you talk about the magnetic and non-magnetic materials, I don't know if you guys have you experimented this? Like when you take 1 rand, when you experiment with 20 cents, two bobo, it doesn't get attracted to magnet. 10 cent, it doesn't get attracted to magnet, but they are all are coins. They are all coins. Why is that the case? It's because of the material that is made up of, the elemental. That's also very important. So there are magnetic materials and there are non-magnetic materials. So only they say here only three really important magnetic materials are as follows. Let's see. Important magnetic materials. It's iron, nickel, and cobalt. Ne? So tomorrow go educate your friends and tell them that these are magnetic materials. Iron can get easily attracted to magnet. Nickel and cobalt, they can also get easily attracted to magnet. And then all other materials,
So,
yes,
so what's the symbol for cobalt?
the symbol for cobalt is Co. It's O,
Okay.
the, small, the smaller yana O.
Okay. Thank
Okay.
you.
I'm sorry, guys. I was supposed to use the periodic table over here. H, I don't know why I did not. So cobalt is C with smaller O, but C with capital letter O. This is a carbon monoxide, but it's not even on the periodic table. We have carbon on the periodic table, we have oxygen on the periodic table. Combine them together, you can form carbon monoxide or you can form carbon dioxide. So CO with smaller yana O there, that's a cobalt. Okay, so uh, so okay, I apologize about that. Uh, all other materials are less non-magnetic. These are less non-magnetic, okay? Such as zinc. I'm sure you are surprised. Zinc, yes, zinc, wood. You don't even have to the wood and paper. Maybe you can be confused about zinc. I remember we used to have argument with some friends here, like mine is made up of nickel, or mine is made up of what if or we used to have those such arguments. So this is where you can just have to understand, or yeah, which is what, which is not what. Okay, all right. And then let's talk about the compounds. We said that the compounds are a combination of elements, and then we represent the compounds with formulas, right? Like H2O, sodium, chloride. Like these are compounds, right? These are compounds. compounds combination of different elements. So sodium chloride is one of the example. Magnesium oxide is one of the example of a compound which is made up of different elements. Copper sulfate, it's one of the examples of a compound. And yeah, this is just the atomic structure on how sodium chloride looks like. So this is a sodium, and these are two molecules of chlorine. And then here we have copper sulfate. This is how copper sulfate looks like. And then here we have magnesium, carbon dioxide. Here is carbon, and here are two molecules of oxygen. And then here we have magnesium oxide, which is a powder in a powdered form. That's how magnesium oxide will look like. So these are examples of compounds, okay? There are many different kinds of compounds. This is just a catch of few nano compounds that we can think of. So these are just few of them, okay? Even carbon dioxide is a compound. I actually wanted to say water. Water, most of the time we consider it as a pure substance, like, which is also a compound though. And that will mark our last session for this notes over here. Let me do this.